In supervised learning, we are giving the machine a set of data which consists of input features and the expected outputs that the machine is expected to provide us. And so from these features, let's call it X, it has to learn the underlying mapping, the underlying function that would produce the correct outcomes Y. So in essence, supervised learning is all about function approximation. Now, when your outputs are discrete in nature, say for instance, trying to recognize the handwritten digits and classifying them between 0 and 9, then this type of supervised learning is called classification. On the other hand, if the outputs are real valued numbers, then it becomes regression. Let's look at an example each. So in case of classification, suppose you'd like to automatically approve or disapprove loan applications. So there are any number of features you can consider. Let's make the process simple. Let's consider only two features. We would consider the income of the applicant and let's say their age, and using that we decide whether we would like to approve the application or not. So this is a classification problem. If you were to visualize it, you can plot it into 2 dimensions, and let's say this is our income, age. So all the applicants who are approved, you can plot them up. So generally this might be okay, and you might have another class, all the disapprovals might be here. So the idea in a classification problem is to learn a decision boundary that allows us to differentiate between the class, such that if you come across an unknown test point, this decision boundary allows us to predict the likely outcome. Regression, on the other hand, as I mentioned, looks at predicting the continuous valued output. So as an example, let's consider predicting house prices. So given a size of a house in meters squared, we would like to predict how much it can go for on the market. So you can go out and collect some bunch of data points, and these are your observations. And the goal here is, given an unknown size of house, we would like to figure out what the price is. So essentially in regression, we would like to fit a curve on the data which more or less faithfully explains the underlying pattern, such that now you are able to predict the required, given an input X, you are able to predict its price. So there are many models that can represent the underlying data. So for instance, in this classification task, you can make a decision boundary which looks like this, or there's yet another decision boundary that is perfectly okay for this given data, it looks like this. In case of regression, you can have any number of lines of best fit, or you can have curves which perfectly fit your data points. So how do we pick the best one? So in order for us to determine how well a model explains the data, we need to look at some form of measuring how good a model is.